Salutations, mini mathematicians. So great to have you. We're starting module 5, and we're going to be talking about what exponential form means and exploring that form. And our lesson purpose today is be able to simplify exponential form expressions and rewrite values in simplified exponential form. And be aware that negative 2 to the fourth power without parentheses and negative 2 in parentheses to the fourth power are not equivalent. So let's explore a little bit about exponential form. So we have our friend Manuel, and he has a new job. Yay! And taking a look at his new job, they offered him 2 options for retirement, option A and option B. And we're going to be looking at our old form we were looking at, linear form versus exponential. So option A is we're getting $100,000 the first year, and every year after that, we're getting $100,000 more. So year 1, option A, we'd get $100,000. And year 2, we're just going to add another $100,000 to $200,000 and so on. So $300,000, $400,000 for our retirement, $500,000 for retirement, and $600,000 for retirement. So again, this is different than salary. This is what we would get for our retirement plan. So option B is, hey, we're going to give you $10 the first year, and every year after that, we're getting 10 times. So to move to the next year, we're going to be multiplying by 10. So what we can think about this is year 1 is 10 to the first power, year 2 is 10 to the second power, which is 100. Year 3 is 10 to the third power, which is 1,000. 3 zeros, exponent of 3. Year 4, 10 to the fourth would be 10,000. Year 5, 10 to the fifth would be 100,000. And 10 to the sixth, $1 million. Okay, so taking a look, what option should he choose? Well, depending on how long he's going to stay with the company, we can say Manuel should choose option B if he plans to stay for more than 5 years. And obviously, if he's gotten this excellent job that he plans to retire in, he's probably going to be there for more than 6 years. Okay, well, let's talk about these 2 options and what it means about their type of growth. So option A, and we're going to be writing an equation for them. So our equation for both of these, we need variables. So X, our independent variable, is going to be the number of years. And Y, our dependent variable, is going to be the money for that year. Okay, so option A, we have Y equals each year he's earning $100,000. So that's your constant rate of change, $100,000 times X. Notice that this is just linear growth. This is what we have been dealing with since module 2, and it's just repeated addition. That is how it grows. It's repeated addition by the same amount each time, that constant rate of change. That's how we get this slope. However, dun, 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 option B is Y equals 10 to the X power. And this, my friends, is exponential growth, which we also call as extreme growth. You got to say it like that, extreme. And the way we grow in this model is repeated. You got it, multiplication. And that's where we get exponents from. So up here for the repeated multiplication, exponents have a base and an exponent, and the exponent tells you how many times you're multiplying the base number by itself. So look up high, that exponent's how many times you multiply. Okay, so let's look at this graphically because we've been looking at so many graphs this year. So our equation for option B is Y equals 10 to the X. Remember, exponential growth. And so we can think about this as this is going to be 10 to the first, which is 10, 10 to the second, which is 100, 10 to the third, which is 1,000, and 10 to the fourth, which is 10,000. I find commas are really helpful when we get into these big numbers. Okay, let's see if we can graph it. We should probably label our x-axes, so years and money is good enough. So at 1, we're getting 10. So notice we're going by half-z's on the x-axis. On the y-axis, we're going by 100z's. Okay, 100z's is not a thing, but it just sounds cute. So 110, I'm going to go up like just a tiny little bit. 2, 100, boom, look at that growth. 3, 1,000, 4, off the charts. Okay, let's see how well we can make this curve. Woo! So extreme. Just make that dot a little bigger so it looks like it goes through it. Wow, look at that extreme growth, you guys. So this equation, y equals 10 to the x power, is an example of an exponential equation. Exponential equations are often used to solve problems including biology, archaeology, and finance. And we're going to be getting into a lot more of those real-world situations in this module. So an exponential equation is in the form y equals a times b to the x power. And thinking about order of operations, PEMDAS, what we would do here, we'd always do that exponent first and then multiply by a. And a here is your starting number or initial value. B is your growth or decay factor. So if we're growing exponentially, that means that this b value is greater than 1. If we're decreasing, if we're decaying exponentially, this b value is going to be greater than 0 but less than 1, so a fraction or a decimal. And x is the number of periods. So for example, here, A, we're starting out just with 1, maybe $1. B, the amount we're growing by is 10. We're growing by 10 each year. And x is the number of periods, so each year. You've seen exponential growth when you looked at compound interest last year in 7th grade. So exponential equations represent situations of extreme growth. Ha, I knew it was there, extreme. Okay, so what we're going to do is we're going to be simplifying. And when we're simplifying, I want you to remember to think about order of operations, which is PEMDAS. And I also want you to think about what are we raising to that power. So in the purpose, I talked to you about if there's parentheses versus not parentheses. So taking a look at number 3 together, this is -5 to the 4th power. So we are going to expand in this lesson and in some of the beginnings of other lessons. And I want you to write this expansion out. And then you can skip showing that expansion as we know the rules. So here, -5 to the 4th power is -5 times -5 times -5 times -5 4 times. Negative times a negative is a positive, negative times a negative is a positive, and a positive times a positive is positive. So here, negative times a negative is positive 25. Negative times a negative is positive 25, and 25 times 25 is, that's right, 625. And let's give it a box or a circle. And if you want to have a calculator nearby, if you weren't sure about 25 times 25, go ahead and have that nearby. But that's all we're using this calculator for, is just multiplying and dividing numbers. So taking a look, number 4, though, is -5 to the 4th power without parentheses. So we can think about number 4 as -1 times 5 to the 4th power. Here, thinking about order of operations, we have to do our exponents before we multiply. So this is going to be -1 times 5 times 5 times 5 times 5. Multiplying, we already know that 5 times 5 times 5 times 5, or 25 times 25, is 625. So let's use that. So we get -625. Excellent. And if you are running out of space, you can always flip over your paper or use the back of your last page to show your work. Just make sure you're numbering it and scanning it in. Okay, so let's take a look at another one. Let's take a look at number 6. So number 6, we have -7 to the 5th power. We're multiplying a negative number an odd number of times. So do you think this is going to be positive or negative? It's going to be negative. So this -7 to the 5th is -7 times -7 times -7 times -7 times -7. 1, 2, 3, 4, 5. And remember, negative times a negative is a positive, so that's 49. Negative times a negative is a positive 49, and then you just have that -7 hanging out. So then what we can do is you can always just grab our calculator. 49 times 49 times 7 is 16,807, and we know it's negative because a positive times a negative. Minus, don't forget we have this other part going on, minus -9 to the second power. So some of you might say, oh, but Miss Barr, negative times the negative makes a positive. Remember, order of operations, we have to do this exponent, all of -9 squared first before we can do that subtraction part. So this is -9 squared, which is -9 times -9. And we know a negative times a negative is positive, so this is 81. So this is a negative number getting more negative, and that's going to end up being negative 16,888. And you can just think about these numbers being added, but that they're negative. Excellent. Take a moment, pause the video, and finish 2, 5, and 7. Go ahead and finish 2, 5, and 7. Okay, let's see how you did. 4 to the third power, maybe you already knew, but it's 4 times 4 times 4. 4 times 4 is 16 times 4 is 64. Nice. 20 to the fourth power, well, that's going to be 20 times 20 times 20 times 20. Got to do the exponents first, plus 20 at the end. Multiply before we add. 20 times 20 times 20 times 20 is 160,000. Plus that 20 gets you 160,020. Really nice work. Number 7. When you got to number 7, you didn't have to expand out -1 13 times, but maybe you did, and that's totally fine. Remember, 1 times 1 is 1. -1 times -1 is +1. And 1 times -1 is -1. So here, because we are raising -1 to the 13 powers, we're going to have 12 negative ones that pair up and all make positive. And we're going to have that one last -1 who doesn't pair up with anyone, and that's so sad. So we're going to end up with just -1. Because it's a negative number raised to an odd power. So that's how we know that it's going to be negative. Awesome. So now we're going to go reversey switchy and write a number in exponential form. When we're writing a number in exponential form, we have to make sure that we are giving it in simplest form, which means the biggest number as your base. So for example, let's look at 128. 128, we're going to use something called a factor tree, and you've seen these before in your mathematical careers. 128, and we're going to think about a number we know that goes into 128. And this is where your calculator can come in handy. So 128, does 4 go into it? Oh yeah, it's 4 and 32. So 4 and 32. And my factor tree might look sometimes different than yours, but we're going to end up with the same answer. So 4 and 32. Well, maybe these are all multiplying by 4, like 4 to some power. Well, 32 is 4 times 8. Okay, so maybe it's 4 to the something power. And 8 is 4, oh, but it's 4 times 2. So since I ended up with 2, I know it must be 2 raised to some power, because all the numbers have to be the same number if we're writing in exponential form. So 4 is 2 times 2, 4 is 2 times 2, and 4 is 2 times 2. Dun, 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 dun. So this ends up being 2, multiplied how many times? 1, 2, 3, 4, 5, 6, 7. So our final answer here is 2 to the 7th power. Really nice work. And again, maybe you run out of space. I don't have a lot of space to do 11, so I'm going to use the back of my previous paper. I'm just going to write number 11, 512. So let's take a look at 512. Remember, we can just do dividing and multiplying today. So 512 divided by, let's try 8. Hey, it's 64. So 8 and 64. So remember, you always want to have the biggest base possible, right? That 808 drum, that big bass. Okay, so 64 we know is also 8 times 8. So we can say 512 is 8 to the third power. Woohoo! Maybe you got excited when you had that 8 there and you kept going and you said, oh, well, 8 is 4 times 2 and 4 is 2 times 2. And you had all these 2's and you were so excited and you went back and you counted them 1, 2, 3, 4, 5, 6, 7, 8, 9. And you're like, well, it's 2 to the ninth. Well, remember that we want the biggest number possible. So just be careful because if you have 2 to the ninth, I can group those together because 2 to the third is 8. So just be aware we want to try and write this in simplest form whenever possible. Okay, so let's take a look at if our number is negative. Ooh, negative numbers. Okay, so I'm going to move over here to 13. So 13, whenever you have a number that's negative, you're always going to start your factor tree. I might as well just keep using my extra paper. Negative 729. Your factor tree is always going to start with -1 because the number on the inside has to be negative. There's no way you're going to be able to multiply a positive number to get to a negative number. It's impossible. So here, what we want to be thinking about is multiplying a number. It's going to end up being negative to get a negative number. We already talked about how you cannot multiply a negative number an even number of times to make a negative. So we know we're probably looking for an odd number here. So 729. And sometimes here, maybe you try a few. Maybe we try 12. Nope, didn't work. 729. Maybe we try 11. Oops. 729 divided by 11. Oh, that didn't work either. Try 9. Ooh, 9 and 81. That's lucky. Oops, I forgot. 729. And we said 9 and 81. And what's cool is we know 81 is 9 and 9. So we have this awesome answer. And don't forget this -1 multiplies to all of these. And so we have -9 to the third power. And if we checked that with our calculator, 9 times 9 times 9 is 729. So you can always double check these. Okay. And notice -9 to the third power with parentheses or without parentheses is equivalent here. So it doesn't matter how you write your answer. Okay, so why don't you go ahead and finish 9, 10, 12, and look at 14 and 15 and see if you can get any conclusions. And we'll check back in a second. Okay, well, let's take a look. So for number 9, -8, we always start with -1 and the number. And then 8, maybe you noticed already, we've been having 4 and 2, and then 2 and 2. So don't forget that this is -2 to the third power, or you can write it as -2 parentheses to the third power. And you can always double check using your calculator. Okay, so let's take a look at 12. When I'm looking at 12 here, you had -243. So your factor tree, you always start with -1 and 243. And 243 is, if I used my calculator, I noticed that it was 3 times 81. And 81 is 9 and 9. So that's 3, 3, 3, and 3. So I have 5 3's and a -1. So this is -3 to the fifth power, or just -3 to the fifth without parentheses. Good. And the last one you had to do, 343. Maybe you got a little bit stuck on that, and that's fine. 343. Notice it's not even, so we're not going to use 2, 4, or 6. The digits 3, 4 plus 3 don't add up to a number divisible by 3, so we know 3 wasn't going to work. So maybe you tried 7 with your calculator and you notice it's 7 and 49, which you were like, oh, thank goodness, 49 is 7 times 7. So we know that 343 is 7 to the third power. So let's think about if we made any conclusions here. So what conclusions can we make? So if we write exponential expression with -1 as its base and results in a positive product, what conclusion can you make about the type of exponent needed? Well, -1 to the n power, where n is even. Example, -1 to the 6th power, -1 to the 4th power, -1 to the 8th power. All those negatives are going to pair up to make a positive. But if you want to write an exponential -1 as the base and result in a negative product, what conclusion can you make about the exponent? So this is -1 to the m power, we'll say. Want to use a different variable where m is odd. Not odd like weird, odd like not divisible by 2 evenly. Example, -1 to the 5th power, or the 3rd power, or the 9th power. We're always going to have that extra negative that didn't pair up to make a positive. Okay, so with our knowledge of exponents from years past and what we've gone over today, we're going to see if these are true or false statements. So I'm going to do 16, 18, and 20 with you. You're going to do 17, 19, and 21 on your own. So 16 says 3 to the 5th is 15. What do we know? True or false? This is false. And it also says explain your reasoning. So this is false. 3 to the 5th power is 3 times 3 times 3 times 3 times 3, 1, 2, 3, 4, 5, which does not equal 3 times 5, which is 15. Okay, so we know that one. Okay, -6 to the 2nd power is 36. Well, 6 times 6 is 36, right? Oh, but you guys remember we have this negative here. So this is also false. How come? Well, this is -1 times 6 to the 2nd power, which is -1 times 36, which is -36. So does it equal 36? It does not equal 36. Perfect. Okay, let's take a look at the next one. The next one says -4 all raised to the 3rd power. Does it equal -4 then to the 3rd power? Well, -4 to the 3rd power is -4 times -4 times -4. And this is negative times 4 times 4 times 4. -4 times -4 is -16, and positive 16, negative times negative is positive. And 16 times -4 is -64. Well, let's see. 4 times 4 is 16. 16 times 4 is 64, and you have this negative. So this one is true. Sorry, I'm using a red pen for all of these. It's a little misleading to our brain. So false, false, true. So go ahead and pause the video and finish 17, 19, and 21, and we will go over them in just a second. Are these statements true or are they false? Okay, let's see how we did. 17, true. -2 to the 5th power with parentheses gives you a -32. -4 with parentheses to the 2nd power does not equal -4 to the 2nd power without parentheses. This is false. Oops, I put a negative sign there. Should be a positive. So 16 does not equal -16. Notice this is -4 times -4, which is positive 16. And this is -1 times 4, which ends up being -16. So this is false. And 21, x to the 5th power is x times x times x times x times x, which is repeated multiplication, where 5 to the x is x plus x plus x plus x plus x. This is repeated addition. Notice these are not equal to each other if x is not equal to 0. If this was 0, then they'd be equal to each other, and that's why they had to say when x is not equal to 0. Cool. Okay, let's keep going. So the next part is asking us to evaluate the expression when x is equal to -3 and to show all of our work. So this is when parentheses are really, really important and showing our work and following order of operations. So when we're going through these problems, again, really important showing your work. If you don't have enough space, grab an extra piece of paper or the back of a previous page, and that's fine. So let's take a look at 22. So 22 is negative x to the second power. So negative, put parentheses where you see your x, and we want x to be negative 3 squared. Now we're going to follow our order of operations. So from here, exponents first. I know you really want to do that negative, negative, but that's not what we are allowed to do. We have to follow the rules of PEMDAS. Write it on your page if you need to. So exponents first. Negative 3 squared, negative 3 times negative 3 is 9. So this ends up being negative 9. Perfect. Taking a look at the next one, and you do have to show your work on these. Taking a look at the next one, we have 5, whatever x is, leave your empty parentheses, squared, minus 5, and then whatever your x is. So it's really nice to put those empty parentheses and then go and put in what your x value is. Following order of operations, we're going to do our exponent first. So this is 5, negative 3 times negative 3 is 9, minus, and 5 times negative 3. So now we can do our multiplication. 5 times 9 is 45. Minus 5 times negative 3 is negative 15. 45 minus minus 15, remember, is 45 plus 15, which gets you 60. Please circle or box your answer. What we need to be really careful about is parentheses, because sometimes we'll have double parentheses. If you're putting parentheses inside parentheses, it's really nice to change those original parentheses to brackets to communicate this. So here I'm going to rewrite this as brackets, negative, and then parentheses around my x, brackets, and then square, plus 4, over negative parentheses squared plus 4. And then go back in and put in what your x is, which is negative 3. When you have all these negative x's in here, these parentheses really are super helpful so you don't make a silly mistake. So now remember your order of operations, PEMDAS or GEMDAS. So inside these parentheses where we have to work first, this grouping symbol, and a negative times a negative is a positive. So we are going to have this equal to 9 squared. Sorry, 3 squared. I was thinking ahead, the next step. Negative times a negative is positive, so 3 squared plus 4 over. And in the denominator, if we are simplifying this, notice we have to do this exponent first before the multiplication. So we would have negative 3 squared is 9, so negative 9 plus 4. Remember, we have to simplify the whole numerator and the whole denominator. So here, 3 squared, 9 plus 4 over negative 9 plus 4. In here, some people decide that they can cancel out these plus 4s and these 9s. You cannot cancel out items in the denominator and the numerator unless everything is being multiplied. These are being added. These are being added. You cannot cancel anything out. So 9 plus 4 is 13, and negative 9 plus 4 is negative 5. So we can write our final answer as negative 13 over 5. Notice there's no cross canceling. If you canceled out the 4s and the 9s, you'd end up with negative 1 or something. Order of operations, we need to simplify the numerator and denominator first. Okay, go ahead and you finish 25, 26, 27. Pause the video, finish those problems. We're going to go over them in just a second. Okay, let's see how you did. 25, we plugged in negative 3 using our parentheses. Remember, they're strong sideways muscles. From here, we took a look, and negative 3 to the third is negative 27. And then negative 3 is plus 3. 4 times negative 27 is negative 108. Plus 3 is negative 105. 26, following order of operations, I've changed these parentheses to brackets, and I put parentheses around my x and plugged in negative 3 for my x's. From here, following order of operations, I have to do what's inside these parentheses first. in these brackets, the grouping. And inside the grouping, I have these exponents. So I did -3 to the fourth, which is positive 81, and -3 squared, which is positive 9. So I have 81 minus 9 in the brackets still. So I had to do what's in the brackets, grouping, to get 72. And then -2 times 72 is -144. Okay, let's take a look at that last one. So this last one, we can think about this as 1 over x divided by x to the fifth. Remember that this big bar, they just mean division. So we can think about how do we divide fractions? Well, we keep the first fraction, change the division to multiplication, and take the reciprocal of the second fraction. So we'd have 1 over -3, plugging in my x, is just -1/3. -3 to the fifth is -243. So this is 1 over -243. And when you multiply across, a negative times a negative is a positive, and you'd have 1 over 729. Nice work. Okay. So what we're going to do is we are just going to look at some quick mistake problem and then a word problem about March Madness, which I'm so excited that this year we will have it again. Okay, so Charlotte simplified this expression and her work is shown below. Did Charlotte simplify the expression correctly? Explain why or why not. If a mistake was made, solve the expression correctly. So I pause the video right now and finish 28, and we will go over our answer. Yes, Charlotte made a mistake, you guys. We cannot cancel out addendums. So addendums are numbers that are being added together. We cannot cancel them out. You can only cancel or reduce factors, and factors meaning the numbers are being multiplied together. So here, they have to keep going from here. So from here, 6 squared is 36, 4 squared is 16, 6 squared is 36, 2 squared is 4. We have to simplify everything in the numerator and everything in the denominator before we can do the division. So from here, 36 plus 16 is 52, 36 minus 4 is 32. Scale it down, 13/8 is your final answer. Nice. Okay, so March Madness, you guys. So March Madness is a single elimination tournament in basketball, NCAA, so college basketball. In a single elimination format, a tournament starts with a certain number of teams and they're paired off for games. And each team plays a game which is called a round. And all the losers in the first round are eliminated. And the second round, all the winning teams are paired off into games. And all the second round losers are then eliminated. So this process continues until there's only 2 teams that remain. And it's the final round where the winner is the champion of the whole tournament. Very exciting. So March Madness starts with 64 teams. So how many rounds are there? So we'll talk about the round and the number of teams. So round 1 has 64 teams. Round 2 will have half as many because half the teams lose and half of them win. Round 3 will half of 32 is 16. Round 4, half of 16 is 8. Round 5, half of 8 is 4. And then the final round, round 6, where there'll be 2 teams to crown a champion. Okay, so another thing we can think about this is how can we make 64? Because we're always taking half, or if we built back upwards, we're multiplying by 2. 2 is our growth factor. So 2 to the 6th power is 64. So we can say that there are 6 rounds. So it says how many teams are in the second round, third round, and fourth round? And we can just use our table here, or because we're thinking about the rounds, for the second round, round 2 has 32 teams. Half of the original teams are eliminated. Making round 3 have 16 teams. And round 4 have 8 teams. Nice. Okay. So how many total games are played? Well, there's a couple ways you can do that. You can think about the number of teams that are playing. Half of that is the number of games. So you can think about 32 plus 16 plus 8 plus 4 plus 2 plus 1 is 63 games. Or what you can think about is that because there's 63 non-champs and 1 champ, there has to be 63 losers, right? So that means that there are 63 games. Awesome. Great job, mini mathematicians. Keep up the awesome work. Do your best and be nice to everyone.